Okay, so we are going to start chapter 1, and in chapter 1 we're going to be looking at statistical concepts. Mostly a lot of terms and ideas that form the framework of most statistical studies, and then we'll start looking at some graphical displays of data, things like pie charts, bar charts. You may have seen those before, but we'll see some others as well. And starting off in section 1.1, we're going to look at statistical basics. And basically the goals here, we're going to look at population and a sample. You'll understand what those terms mean: qualitative, quantitative, and then looking at quantitative data, determining if it's continuous or discrete. So we'll have all those things in this section. Starting out with a population versus a sample, I want to initially just define statistics. What does statistics mean? And basically it's the science of collecting, organizing, analyzing, and making inferences from data. Here we go. Also, statistics is kind of an interesting term. It has two meanings in the world of statistics. It's basically the term used to describe the science, collecting your data, organizing your data, analyzing, making inferences from it. But it also is the term applied to data collected from a sample. So if you go out and collect data from a sample of the population, we'll talk about these terms more here in a second, that data that you've collected would be considered statistics. So it's the name for the science itself, and it's the name for data that you collect from samples. All right, so the study of statistics requires knowledge of special terminology. And really, this is one of the most important parts of statistics to understand. There's a lot of math in it, but more importantly, the terms, knowing what the terms mean, because the terms are going to determine what sort of mathematical operations you're going to use in order to help answer questions. So it's really important that you know the terms. And if you need to make some flashcards with this so you get them down, I recommend that. But however you approach it, knowing that the terminology is a big part of statistics, and really one of the main reasons that some people struggle with it, more so than the math side, it's going to be really helpful in helping you get through this. So first statistical terms that we'll look at: a variable. And basically it's any characteristic that is measured from an object or an individual. So, if I'm going out there and I'm measuring heights, for each different person, their height could vary. So that's why we call the height a variable. With the population, it's just a set of measurements or observations from all objects under a study. So if I was studying Coconino Community College students, the population would be every student that was enrolled, every single one of them, in the Coconino Community College. The sample is a set of measurements or observations from some objects under a study, basically a subset of the population. So if I was doing a study on all Coconino Community College students, a sample of that might be 30 people that I randomly selected from all of the enrolled students. So the sample is a smaller part of the population. And even the word sample, when if you're going out to like a buffet and you're sampling different things, you're just taking a little bit of each. And that's kind of the idea in statistics with a sample. You're taking a little bit of the population to try and get an idea of what the whole population is doing. And just like when you're sampling food, maybe if you go to one part of the buffet tray, you don't get all the pieces that are in there. I know with I love Chinese food, and sometimes there's a lot of different things in there. Well, maybe I happen to scoop out the one and I didn't get any of the green pea pods in there. So I don't get the full representation of the flavors because I missed that when I scooped it out. And that's something we'll address later, this idea that your sample may not be a good representation of the population. And we'll look at ways to help make that better. But overall, sample is a small part of the whole that you're studying. So, bigger example here, if we are studying heights of CCC students, and select 35 students for this purpose. Then height is the variable. All CCC students are the population. And I'm going to use an abbreviation here. It's a very common abbreviation for population, just POP apostrophe N. You can use that as much as you want. So all the students will be the population, and the 35 selected are the sample. Now, don't forget that I will be posting these in a place where you can reply. I'm going to try and set it up so that they're discussions. The videos will be embedded in the discussions. And that way you can ask questions about the videos in line. And if you do ask a question about a video, maybe point out the time that you're seeing, so that I have an idea of where to go and clear things up for you. Right, and then a quick little visual using like a Venn diagram type approach. If you had a circle here, that would be the population, the whole population. Within that would be a smaller circle, and that would be your sample. Okay, so qualitative versus quantitative. The data that you collect in statistics can be classified using these special terms that we're going to see coming up here. And we're going to see a lot of special terms for statistics overall, as I said, but some general terms that we need to look at initially before we get into qualitative versus quantitative is the idea of a data set. And a data set is just a collection of values called data points or data values. Anything that you're collecting from your sample, even from the population, could form a data set. All the salaries of people, the heights, the weights, ages, gender, favorite colors, all those things could form a data set. In this book and in many others, capital N is going to represent the number of data points in a population, while the little n, lowercase n, is the number of data points in a sample. So big N for population, smaller n for a sample. And that kind of goes in the idea that, the sample is a smaller part of the population. A data value that is much higher or lower than all the other data values is called an outlier. So, putting this in a real life perspective, a CEO's salary compared to all the other workers at a company is probably going to be an outlier salary. They're going to make much more than the typical worker. And sometimes outliers are just unusual data values that are very interesting and should be studied further. Sometimes they're mistakes. If you're measuring things, sometimes your measuring equipment will have an error, and if it has an error, it's going to give you some crazy value. And it's still worth looking into because you want to know if your measuring equipment is, not functioning properly. But sometimes the outliers are like, a person's salary. It's interesting to be like, wow, they make so much more than everybody else. But at any rate, they are something that can be looked into or might indicate a problem. And you'll need to figure out which is which, depending on what you're doing. Okay. Let's go ahead and take a look at the two main types of data values that you can collect. Going to be qualitative and quantitative. Spelled similarly in a lot of ways, but quality is kind of the basis of the first one. Quantity is the basis of the second one. So a qualitative variable, it's a variable that represents a characteristic. So just something that you're interested in measuring. Qualitative variables are not inherently numbers. So they're going to be words usually. And they cannot be added, multiplied, or averaged, but they can be represented graphically with graphs such as a bar graph. So an example of this would be favorite color. You're going to respond with a word to that. What's your favorite color? Green. It's going to be something where you're responding with a word. High school attended. It's another one where it's going to be a word that you're going to use or words that you're going to use to describe the high school that you attended. The make of a car. That would also be something like, it's a Ford, a Chevy, whatever, etc. Also, an area code, believe it or not. Even though this is a number, the area code, it's a quality. If you add area codes together, it doesn't really give you anything meaningful. It's not going to be like, oh, it's the total area code. That has meaning. It has no meaning. So sometimes numbers are qualitative because they attribute a quality to something as opposed to something you can add together meaningfully. So area code is a quality. All right, and then quantitative, it's a numerical variable. Quantitative, always going to be numbers. So it's something that represents a measurable quantity, height, weight, the length of, your room, something like that. It's all going to be quantitative. They're inherently numbers. They can be added, multiplied, averaged, displayed graphically. Like if I added up all the heights, I would get a total height for a population. That is meaning when you add up all the heights. And that's what makes, the numbers that you use in quantitative different than any numbers that you might see in qualitative. When you add them together, they're meaningful. So an example here, height, weight, number of boxes that you have in storage, anything that you can count or measure is going to be something that is quantitative. So furthermore, quantitative variables can be described as either continuous or discrete. And I'm using the free version of this recording software, and it cuts me off after 15 minutes. So this is a good place to kind of, just stop and, take a break, absorb these terms a little, think about them a little, and then move on to the part 2 video for section 1.1.